Hello, listeners. This is Mike, your host. If you are enjoying these archive episodes, please consider supporting the podcast by going to the homepage, spacerockethistory.com, and clicking on the orange donate button or the Patreon link. Hopefully, with your support, I can continue to release these archive episodes. Thanks.
We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard.
Godspeed, John Glenn.
Roger, 0G, and I feel fine.
I feel okay, I'm on.
How does it feel for the United States to be the new record holder?
At last, huh? When that baby lights, there's no doubt about it.
Liftoff. We have a liftoff. 32 minutes past the hour. Liftoff on Apollo 11.
Listen, Tranquility Base here. The Eagle has landed.
That's one small step for man, one giant leap for mankind.
Hello and welcome. This is Michael Annis, and you're listening to episode 155 of the Space Rocket History Podcast. And now, Apollo 7, Assembly, Testing, Training, and Launch. The first stage of Apollo 7 was the S-1B stage. It was built by the Chrysler Corporation at the Michoud Assembly Facility in New Orleans. It was powered by 8 H-1 rocket engines burning RP-1 kerosene fuel with liquid oxygen. 8 Redstone tanks, 4 holding fuel and 4 holding liquid oxygen, were clustered around a Jupiter rocket liquid oxygen tank. The 4 outboard engines were mounted on gimbals, allowing them to be steered to control the rocket. 8 fins surrounding the base thrust structure provided aerodynamic stability and control. The total thrust for the S-1B stage was 1.6 million pounds. The second stage was the S-4B-200. It was built by Douglas Aircraft Company at Huntington Beach, California. The S-4B-200 model was similar to the S-4B-500 third stage used on the Saturn V, with the exception of the interstage adapter and smaller auxiliary propulsion control modules. It was powered by a single J2 engine. The fuel and oxidizer tanks shared a common bulkhead, which saved about 10 tons of weight and reduced vehicle length over 10 feet. It was fueled by liquid hydrogen with a liquid oxygen oxidizer. Total thrust for the S-4B was 210,000 pounds. Next on the stack was the LEM adapter, and then the service and command module. Command Service Module 101 started through the manufacturing cycle early in 1966. By July, it had been formed, wired, fitted with subsystems, and made ready for testing. After the Apollo 1 fire in January 1967, changes had to be made, mainly in the wiring, hatch areas, and the forward egress tunnel. It was December before the spacecraft came back into testing. Command Service Module 101 passed through a 3-phase customer acceptance review. During the third session, held in Downey on May 7, 1968, no items showed up that might be a constraint to launch. North American cleared up what few deficiencies, there were 13, and shipped the craft to Kennedy on May 30, 1967. Deputy Administrator George Low had spent a lot of time thinking about how to get a flight to the moon before 1968 ended, but Apollo 7 still held his close attention. He worried about Apollo 7 because it was the first attempt to get a crew into space after Apollo 1. After rereading the evaluations of the Apollo 4, 5, and 6 flights, Low asked Simpkinson, one of his chief troubleshooters, to make up a worry list of things that might have been overlooked. He also asked John Hodges' crew's Safety Review Board to question all the judgment decisions that separately had made good sense, making sure that the sum of them still did make good sense. Aaron Cohen, who reviewed them for Lowe, concluded that individually and collectively these decisions had been sound. Out at North American, Dale Myers was doing the same soul-searching, looking specifically at the 137 changes that had resulted from the Apollo 1 fire. All this care paid off. At the Flight Readiness Review on September 20th, Myers reported that Command Service Module 101 was a very good spacecraft. The Launch Preparations Group agreed. Now it was up to the flight crew to prove them right. For almost a year, the Sherrill, Isley, and Cunningham team had stayed with the spacecraft in California. When the spacecraft moved to Florida in June 1968 for launch preparations, the crew followed. The astronauts had not devoted all their time to Command Service Module 101, however. During the 6 months before launch in October 1968, they had spent nearly 600 hours in the Command Module Simulator, operating the 725 manual controls and reacting to simulated emergencies and malfunctioning systems. They had also been in the spacecraft during an altitude chamber test, checked out the slide wire for a launch pad emergency escape test, crawled out of a model spacecraft in the Gulf of Mexico to practice recovery, listened to briefings on systems and experiments, visited the Moorhead Planetarium in North Carolina and the Griffith Planetarium in California for celestial navigation training, worked with the crew systems people in getting their suits and supporting equipment ready, and studied mission plans and other documentation. Sherrill's team also received the benefit, through briefings or written reports, of the activities of other astronauts who were studying, participating in, or training on specific pieces of the Apollo systems. For example, before Command Service Module 101 left the factory at Downey, it went through a test to make sure that its systems performed properly and in harmony. Astronaut John Young attended this session and noted that, in some instances, the computer, inverters, pumps, fans, and radios were, in his opinion, operated longer than was either necessary or good for the equipment. He also found that when deficiencies were uncovered, everything stopped while discrepancy reports were written on the spot. On the positive side, however, Young thought the crew checklist for time-critical sequences was excellent. From there, he went on, item by item, finally concluding that Command Service Module 101 was a pretty clean machine. In addition to their flight training, the Apollo 7 crew had to exercise to keep physically fit, to guard themselves against illness, and to fly their T-38 jet aircraft from place to place to maintain proficiency in high-performance machines. Sherrill, Isley, and Cunningham had been doing this detailed work with only an occasional night off to see a soccer match or some other sports event for more than a year. Command Service Module 101 had spent even longer getting ready for its voyage. At this point, Sherrill could have wondered if he was typecast for engineering flights only. Both his Mercury and Gemini flights found him facing a situation similar to what he was about to encounter in Apollo 7. In 1962, his Mercury Atlas 8 mission had been a 6-orbit engineering test to see if Mercury's legs might be stretched to a full day's flight. 3 years later, his Gemini 6 had been an engineering test to attempt the first rendezvous with a second vehicle in space, and his Apollo flight would be an engineering flight as well. Which brings us to one of the more controversial aspects of the Apollo 7 flight. One piece of equipment got aboard Apollo 7 and all subsequent manned flights in spite of the insistence of most engineers that it was not needed and the ambivalence of the test pilot-oriented crews. This was the television camera. Ever since September 1963, when NASA had first directed North American to install a portable camera in the spacecraft, that device had been going in and out of the craft as though it were caught in a revolving door. Wrestling with the constant problem of overweight, many engineers viewed television cameras only as nice things to have. On occasions, when kilograms or even grams were being shaved from the command module, the camera was among the first item to go. There were those, however, who persistently argued for the inclusion of television. NASA personnel in charge of public information activities, Julian Scheer in Washington and Paul Haney in Houston, naturally favored the use of television. But there was one management-level engineer in the Houston Apollo office who agreed with them. In the spring of 1964, William A. Lee wrote, "I take typewriter in hand to plead once more for including in-flight TV. Since it has little or no engineering value, the weight penalty must be assessed against a different set of standards. One objective of the Apollo program is to impress the world with our space supremacy. It may be assumed that the first attempt to land on the moon will have generated a higher degree of interest around the world. A large portion of the civilized world will be at their TV sets wondering whether the attempt will succeed or fail. The question before the House is whether the public will receive their report of this climactic moment visually or by voice alone." End quote. 4 years later, following more trips through the revolving door, television became part of Apollo when George Low was told to install a camera on Command Service Module 101. Now let's talk about the objectives for Apollo 7.
The purpose of the flight of Apollo 7 could be stated very simply. Prove that the spacecraft command and service modules would function properly in space, long enough to carry men to the moon and back. Accomplishing this was considerably less simple. It meant showing that a brand new spacecraft, far more complicated than its predecessors, would operate so well it could be trusted to take men well beyond near-Earth orbit.
The primary objectives for Apollo 7, an engineering test flight, were simple. Demonstrate Command Service Module crew performance, demonstrate crew space vehicle mission support facilities performance during a manned Command Service Module mission, and demonstrate Command Service Module rendezvous capability. The crew would test the life support, propulsion, guidance, and control systems during this open-ended mission, meaning it would be extended as it passed each test. In Mission Control, Glenn Lunney was Prime Flight Director, with Gene Kranz and Gerald Griffith handling the second and third shifts. The countdown for Apollo 7 took 2 days. When it started, controllers were relieved because the tedium of the training was over. All the controllers knew if Apollo 7 succeeded, the U.S. would be on schedule for a lunar landing. But if it failed, the chances were high that there would be no lunar landing before the end of the decade. As the Apollo 7 crew and their guests ate the traditional launch day breakfast, a few nostalgic thoughts flitted through the minds of at least some present. For at least 2 members of the morning get-together, the thoughts had to be tinged with sadness. On September 16th, to the surprise of nearly everyone, Administrator Webb announced that he was retiring on October 6th, his 62nd birthday. After almost 8 years at the helm of NASA, Webb stepped down, apparently to smooth the transition to a new administration in the White House. Payne, his deputy, became the acting administrator. 4 days after the Webb announcement, Schirra said this would be his last mission, as he too planned to retire. Now, let's listen to the countdown of Apollo 7 as it was broadcast live from the Cape.
The proper ignition. The S-1B first stage fuel tank is pressurized, and the second stage liquid oxygen tank pressurizing at this time. Now coming up on the 2-minute mark, T-minus 2 minutes and counting, T-minus 2. Not as much reports now on the communication circuits as everybody stands by monitoring the various consoles and watching the various parameters to ensure everything is okay. T-minus 1 hour, 1 minute, 43 seconds and counting. We are still proceeding.
And just at this moment, a great gust of wind sweeps our press camp here.
90-second mark in our countdown. Mark, T-minus 90 seconds and counting. T-minus 90. We have conditioned the liquid oxygen in the first stage of the Saturn launch vehicle. All tanks in the 2 stages now pressurizing. Most of the work over these final several minutes concerned with the launch vehicle, directed by the test conductor, Don Carlson. 1 minute, 10 seconds and counting. We still are go at this time. Coming up on 1 minute. Mark, T-minus 60 seconds and counting. We are go for Apollo 7 at this time.
This is the first manned test of the Saturn 1B.
Now pressurized, and the vehicle is go, as is the spacecraft at this time.
First American 3-man flight.
T-minus 40 seconds and counting.
First step in a final series of tests to get American on the moon by the end of 1969.
30 seconds and counting. We'll get ignition of those 8 engines in the first stage at the 3-second mark in the countdown. Now T-minus 21 seconds and counting. We have completed our power transfer. The Saturn 1B launch vehicle, which now weighs 1.3 million pounds, is ready to go. Coming up on the 10-second mark. 10, 9, 8, 7, 6, 5, 4, 3, 2. We have ignition. Commit liftoff. We have liftoff.
Slowly.
This is launch control. We have cleared the tower.
Tower clear. 5 seconds for that sound reaches.
The roll program has commenced.
A beauty of an absolute cloudless sky. Scheduled. It looks good. From here, it looks fine. Straight and true on its course. Get a good view of it there with our long-range camera. Schirra, Don Isley, Walter Cunningham, the latter two making their first space flight. Wally Schirra, his third, riding that
1 minute, 20 seconds into the flight.
big spacecraft
and in the air.
The voices now of mission control change from Jack King to
1
Paul
minute,
Haney.
40 seconds.
They've gone through maximum dynamic pressure.
Flight director asked the flight dynamics officer if he likes it, and he says, yes, sir, it looks good.
Look at the flame. 700 gallons of RP1 and liquid oxidizer burning up there every second. That thing developing 1,000,000.
Coming up on 2 minutes, mark 2 minutes. We're having a status check. Apollo 7 has been given a go for staging.
Go for staging, the separation of that first stage. That comes in about
2 minutes,
10 minutes, 10 seconds from now. That's the first critical point after liftoff.
Inboard engines have shut down.
And they're staging.
Outboard engines have shut down. Schirra called both events. He's got ignition, and he says we're up to thrust on the second stage.
That is our Igor
The
long-range
thrust is
camera.
okay at 2 minutes, 40 seconds into the flight.
So the 15th consecutive successful flight of the
Well, it
S1B,
is all
Saturn
beautiful.
1B.
That tower has really jettisoned. It went way out. We're nearly 50 miles altitude now and about 60 miles downrange.
You see the escape tower tumbling up there in the upper
3
left-hand
minutes,
side of the
5
screen.
seconds into the flight.
He got the separation plan from the first section, and the second
It's just
stage
up
has
with
ignited.
Capcom here in Houston. A very clean voice communication today. 3 minutes, 25 seconds into the flight.
This is the best view we've ever had from our magnificent Igor camera.
Trajectory and guidance give another go here.
And of course,
It is a little bumpy on the second stage, a little bumpy. But we can't hear any complaints. 70 miles altitude and about 120 miles downrange.
this second stage burns until 10 minutes and 15 seconds into the flight. Another 6 minutes. That's a 225,000
seconds into the flight.
pound thrust engine.
Schirra says the gimbal check looks very good. And his observation is the 1G stuff is great. Apparently the G loads were quite low.
That means
We've been monitoring Schirra's heart rate because that's the only physical parameter we have coming through, and it at launch and through the early stages ran about 90 to 92 beats. 4 minutes, 50 seconds into the flight. The flight director is polling all his stations here and is getting enthusiastic goes at every console. 5 minutes into the flight. And we've heard from Don Isley, who reported the spacecraft guidance go. 90 miles altitude now.
Bill Stout out there in Downey. Don Isley is monitoring some of these instruments, and is Cunningham monitoring some too?
5 minutes and 25
Nick,
seconds into the flight.
Can you tell us, would Isley and Cunningham both be watching instruments, or is that one man's job?
Right. Cunningham would be watching most of the spacecraft status gauges.
Exactly.
And Don Isley would be looking at the information being displayed on the computer here, such as altitude, what his velocity is, and his launch parameters.
Wally says she's riding like a dream at 5 minutes, 58 seconds into the flight.
It certainly sounds as though no one has had anything to complain about yet. All the words back from the spacecraft are gleeful, delighted, smooth, pleasant, and so forth. What would that look like here? Would there be any instrument, going back to what Schirra said, a little bumpy in the second stage? How would you have seen that on your display?
Well, I think he probably could have seen this off his attitude indicator.
The first manned American spaceflight in 22 months lifted off from Launch Complex 34 at 10:05 a.m. local time on Friday, October 22, 1968. Liftoff proceeded flawlessly. The Saturn 1B performed well on its first manned launch and there were no significant anomalies during the boost phase. More than 600 news media representatives watched the first manned Apollo flight speed skyward from Launch Complex 34. Once Saturn 1B-205 and Command Service Module 101 cleared the pad in Florida, the three-shift mission control team in Houston took over. Sherrill, Isley, and Cunningham inside the command module had listened to the sound of propellants rushing into the firing chambers, had noticed the vehicles swaying slightly, and had felt the vibrations at ignition. 10.5 minutes after launch, with little bumpiness and low G loads during acceleration, Apollo 7 reached the first stage of its journey, an orbital path 227 by 285 kilometers above the Earth. Sherrill described it as very smooth riding compared to the rough, bumpy Titan II used to launch the Gemini spacecraft. Thanks for listening to this archive episode of the Space Rocket History Podcast. If you are financially able, please support the podcast by going to the homepage, spacerockethistory.com, and clicking on the orange Donate button or the Patreon link. Thanks.